And the slides is taken from the United Transformer course. And the slide is actually made by Mark Chen from OpenAI. Okay, so let's move down. So first, they basically walk through the history in language model. When I say like a language modeling, it's usually just like to predict the current the next word based on the preceding words. Say you based on the previous like 2 words, or maybe longer sequence like based on the previous 10 words, and the goal is to predict the next word. So that's language modeling. So in the beginning, I think people use like a lookup or statistical methods, right, to figure out, okay, based on the observed sequence of words, what is the next word? And here it is like based on 2 preceding words, then it's like a 3-gram model. That's in the beginning how people kind of generate the next predicted word for the language modeling. And here is a sample of what this model generates. So you see that it actually doesn't mean anything, and it puts something like totally irrelevant together, like 0.63%. So maybe it makes some sense, like if you just look at like 3 or 4 words, but putting together, it doesn't make sense. So that's this how this model like begins with the 3-gram model. Let me. So next, and then people implement the recurrent neural network, right? So the recurrent neural network is mainly targeted to model the sequences. Yeah, so this is based like a recurrent neural network based on the next prediction is based on the input and also based on the hidden state from the previous cell, which the hidden state kind of represents all the information for the previous series. And here is the output sample. So you see that it starts to, well, make some coherent messages, but still, like if you look like a very long, like if you look at like a whole sentence, it still doesn't make sense in the whole sentence. So people actually find that with a simple recurrent neural network, it's very hard to model the long sequence, right? It's very challenging, you know, to record all the information in the long sequence, and that leads to the next model, which is the LSTM model. Right, so the long short-term memory, which is mainly to pass the information like far back directly to current state by designing the gates there. So and here is the big LSTM. Well, this paper basically tries to explore the limitation of the language modeling with LSTM. Like in addition to this big LSTM, it even do at the child level. Like instead of like the word level, it does at the child level, means that it will model like the THE as the input rather than the as the input. And also at the output, it also does like another LSTM like at the child level. And they find that with like trying to like push the limits for the LSTM and find that yeah, it begins to generate a sentence that makes more sense, since the LSTM is targeted to encode like information for longer sequences. So that's the LSTM. And then in 2019, that gave birth to the transformer. Well, the transformer said, oh, the attention is all you need. Basically, you don't need any recurrent unit in there. You just need attention in there. So if you are interested in like what is exactly the attention, go refer to that blog link that I sent in the chat. So in the transformer, well, it actually kind of brings up the state of the art for various like a task in language model, and including the language modeling, which is to complete a paragraph like based on the inputs over here, right? So the prompting means like you just give the model some beginning phrases, say such as like a wins over Kansas, and then the model will like iteratively, like always predict the next word, and it's going to kind of generate a paragraph or maybe even several paragraphs out of that. Right, and you see that it start make some coherent output, like paragraph wide, right? So it kind of tells that yeah, some of this can be made up, such as the word is totally misspelled, and it's made up, and yeah. Then and this is like how the beginning performance of the transformer looks like. And I want you to remember the prompt. The prompt is very important for like a language modeling, like including the GPT model, which is used in ChatGPT. Right, the prompt is basically you just initialize your input, like with just given a few words, just like what you ask the ChatGPT, right? So you prompt the model with the question you ask, and then the model generates output, which is the answer to your question. So that's the prompting. We call it prompting in language processing. And since then, people start to develop more and more bigger and bigger transformers. So when I say bigger, I mean that the parameters. So usually the size of the model is based on the number of parameters in a model that is going to learn through the training process, right? So I think like previously, like usually the parameters are like for GPT-1, I think it's below 1 million, maybe just a few few millions. And then GPT-2 kind of goes beyond like 1 billion, and GPT-3 and even much larger over there. So when people like develop the GPT-2 model, so the big transformer, right? That is the first leap towards like a big transformer, a GPT model, and then people find that, okay, based on this input, and then if I ask the model to complete the following paragraphs, it starts to make more sense, although the input is basically made up, right? So discover some unicorns, and actually the GPT model can continuously make up the story for you, and actually the sentence are quite coherent, and even the meanings or the message is quite coherent in the output. And then people doesn't also, this is another example showing that the paragraphs kind of learns to always like refers to the same person. So the same person kind of shows up frequently in several paragraphs to make the message coherent. So basically they learn how to refer to each other in the paragraphs. Then that leads to the GPT-3, which is like a very big transformer. And I think the GPT-4 is going to be released soon, I guess, maybe by Microsoft collaborated with OpenAI. And then you see the GPT-3. I think this is like some paragraph taken from a novel, the three-body problem novel, and then you ask the GPT-3 model to complete the following paragraph, and you see that, yeah, actually it writes in a novel style, right? Not only it generates coherent meaning, but it even can like follow the style of the novel, and you see that it's very literature kind of style with the output. So actually, a bigger model can, learns not only like how to put the meaningful phrases, but also like learns the style of the language. Okay. Okay. And so, and then there's a question, a test to the GPT-3 model is, can that GPT-3 just generate some like a kind of the fake news article, right? And it basically, and then the output is going to be read by humans, and to see if that news article is generated by AI or is the actual news article. And then here it kind of says the accuracy. So if it's a random guess, it will be like a 50%. So every time you presented a news article, you just randomly pick yes or no, like yes generated by AI or like a written by real person. And you see that when we increase the model size, so basically this is a number of parameters at log scale. So you see, like if we increase the model size, the GPT-3, like the generated news articles by GPT-3 is very kind of approaching this line. Basically, human cannot tell the difference. So human cannot like just by reading that article cannot tell whether it's generated by AI or written by a real human. So I think the progress made is really amazing of like teaching machine to write real paragraphs. Although I think there's still kind of a gap to figure out to put the logics into the outputs as well. Okay, I think that's a brief history of from where in the beginning, like we start with the gram 3 model, right? Just use the 2 words to predict the next word, and then we invent the basic recurrent neural network, and to increase and to better represent longer sequence, LSTM was invented. And then the transformer, and then from the invention of the transformer till now, people basically trying to encourage and train larger and larger model based on the transformers. And that leads to us like where we are right now with the chat GPT-3 and even like a GPT-4 model. So any questions so far before we move to the next section?
Yes, I was wondering, how does the system resolve conflicting information on different web pages?
Mm-hmm.
Is any of this patented, or is it just free for anyone to implement?
You mean what do you mean by like everyone to implement?
Well, I just wondered if there's any patents on this that are held by OpenAI, or whether people can just watch these lectures, for example, and implement it themselves, their own system, and that's fine.
No, so right now the OpenAI model is closed. It's not open source, and it's since I think Microsoft has invested a lot into OpenAI, and I think the GPT model is kind of their like in-house model right now. And although and I think right now they open the API, right? So you can use their API to get the output from the model.
Okay, and what if the system scrapes different web pages that have conflicting information with respect to each other? How does the model resolve that conflicting information?
Yeah. So that will based on like which is the more of the majority. So it's more always like a statistical test. And if the data is biased, then the model is also biased, right? I think it will learn like what is the kind of the major voice or major opinion in the training set that they have looked at.
So it's sort of like Wikipedia, I guess. If a bunch of people post web pages that have incorrect information on them on purpose, then that can make its way into the model.
Yes, yeah. So I think that's why it's also very important to filter what goes into the model, right? So I think OpenAI also hired a team like to focus on just filtering out the violent and the best data sets.
Right. Okay, thank you.
In the beginning. And another note is, I don't think right now like one individual person can train this because it's just too big. The data is also very big. Since it's trained on like a lot of, I don't know the size, but it can be like a million, billions of, or maybe trillions, like in terms of the data size. And I think Microsoft has like a Microsoft Cloud has been offered to OpenAI to train such a large model.
Thank you.
Yeah. Any other question?
Yeah, I was curious if you refer back to, I think you call it 3-gram model. If you went up from 3 to 10, 20 or so, would that be a similar model? Is that what you get with the GPT, or is what would you get if you scale that model up, if you could?
Yeah, but I still don't think that will beat the GPT model. Yeah, you can model it like a Markov chain or like a transition function. Like you can model some transition function like learns to map from the sequence of, say, just 10 words or maybe a longer sequence to the final output. Yeah, but I think that model is isn't as powerful as the ChatGPT or deep learning model, because the deep learning, since you can have a lot more parameters in the model, and it means that it can model really complicated functions rather than just like a simple maybe some fixed form statistical functions over there.
Okay, thanks.
Yeah. Okay. And next, Mark introduced a history of language modeling at OpenAI. And I think he specifically mentioned like how they train the GPT model. Actually, the model is trained based on like unsupervised data sets, like unsupervised learning. So first, I think before understanding how, right, how does it like train on the unsupervised learning? The first question is like, why unsupervised learning? Well, because, well, the supervised learning works great, right? So if you have the labels, then yeah, it will be super, like you can directly just train the supervised model with the labels and the performance will be great. And usually the deep learning models require the larger the set of labels, the better the performance. But people find that actually the large labeled data sets are hard to find and sometimes very expensive to get, right? So the labels are scarce. Well, you sometimes you just have the data. The data here, I mean, all the text on like open and public on internet. So you can get all this data like maybe freely. I don't know the copyright, but you can get all this text like open public on internet. So you can get lots of like this text data freely, but the labels are very scarce. So basically you cannot, you know, directly just train a supervised model with all these labels. Then can we also learn from the unlabeled data? Can we just forget about getting more labels? Can we just learn the language patterns directly from unlabeled data? I think it's an idea just like us, like as human beings, like how we write, how we learn to write. Basically, we read lots of stuff, right? So we read novels, we read news, etc. So once we read enough, this unsupervised text, and then we kind of gradually learn like, okay, how can I write a new article myself? So the same idea there. So basically just show the unlabeled data, like and to, you know, let the model learn directly from that. So how the model directly learn from the unsupervised data? Yeah. So there is lots of unlabeled data, because like we are on the free public the internet, right? So internet itself generates much data, many data during one day. So then how can we leverage this these data sets for unsupervised learning? GPT, what it does is use the autoregressive generative model. So the autoregressive generative model actually is very similar to those like 3 gram, like a 3 gram, 10 gram model, right? Basically, you always use the previous words in that sentence or in that paragraph as the input and trying to predict the next word based on the previous sequence. So that's an auto-regressive model. So it says like what I cannot create, I do not understand. And if I can create, I also kind of understand. Well, it's still question mark over here. But if we can do like a very well at next token prediction, and maybe there's some reasoning there. Maybe the model can learn directly from that, like knowing like how to write better just based on all the previous sequence of words. And when I say like a sequence in terms of the GPT, it can be hundreds or even more. So it's not like just 10 grams or just a few grams, but it can actually refer to hundreds of grams in their model. Or maybe 1,000. I don't know what's exact size. And they also show that even the unsupervised learning, it learns something meaningful. So in this paper, they show that basically you just show this text to a simple LSTM model, and then use the LSTM model to just predict the next word, right? So based on the previous sequence, predict the next word. And then what they find that it's like closer to the last layer, they identify a neuron. Basically, the neuron is outputting, it's a kind of a sentiment neuron, like outputting whether the meaning, the word, like is negative or positive in that paragraph. So if that neuron is turned on, it's kind of positive, and if the neuron is turned off, it's a negative. And yeah, so this is kind of the highlights of what is where is the negative, where is the positive. So this is like trained without giving any labels of sentiment. But the language model, just by doing the next word prediction, the language model kind of learn itself, like what is negative, what is positive when it sees enough text. I think this is a pretty interesting discovery. Okay, so before we go to the GPT-1, GPT-2, so any question?
I was wondering, yeah, I was wondering how difficult is it to implement attribution, meaning when it writes a story to tell you where that story came from?
When you write a story, where is that story comes from? So and you want to write like on top of?
No, I mean like list the web pages, for example, where it primarily found the information from which it's drawing to write the story.
Does it, another way of asking the question, does it cite its sources? For example, if you're using this model to help write, where do the sources come from? Is there citation?
Yeah, so the OpenAI, the ChatGPT doesn't have any references, but I do think the Bing, like kind of integrated with the ChatGPT, they have the references there.
Thank you.
Yeah, actually, when I first tried the ChatGPT, I said, well, if it can tell me the sources of the information where it relies on and relies on those information, it generates this paragraph. I think that will be more useful since I have a way to check whether it's valid. It has the root there, right? But OpenAI, I think the ChatGPT doesn't have it. But later on, when I see the Bing release that, and it does have the links there. So I think that will kind of safeguard to make sure that the information, so we can still have a way to check whether the information is valid or not.
Very interesting.
Yeah, that's a combination of the GPT with the search engine, right? Because the search engine has lots of links and trying to reference on which is most relevant, which links of sources are most relevant for the generated paragraph. Okay, and then the GPT-1 model. So if you go to the link that I previously sent, so in that it has if you move to the bottom, there's like a GPT. So specifically like what is the GPT architecture? And to understand that, you need to understand what is a transformer architecture. And then GPT is nothing but just stacks of the decoders in the transformer. So the transformer has encoder and decoder, and GPT is just use the decoder part. And it's a generative modeling, means that it will always use the previous text to kind of predict the subsequent text. And the output also include a task classifier so that you can adapt it to classification task. So when the GPT-1 is first published, it shows that it already kind of beats the state-of-the-art method across various different text tasks, like the textual entailment or similarity between the sentences, or common sense reasoning or sentiment. Sentiment actually still hasn't beaten the sentiment yet, but there's some other benchmark that it actually beats the state of the art across several benchmark data set. And in the GPT-1, it used only 12 layers of the decoders.
So one question I have is that what was the state of the art when GPT-1 was released?
Yeah, so I think will be good to look at the paper, but as I know that almost the BERT, right? So I think the BERT is also a popular kind of basically the stacks of encoders in the transformers at that time. So I think the BERT and GPT may be kind of released at the same time. I'm not sure whether the state of the art is the result from the BERT model or it's before the BERT period. So then it will be kind of the encoder decoder like LSTM based model.
Okay, got it.
Yeah, let me share the link one more time. So you should have from the link, you should have all the information from the first session on introduction to transformers, the BERT and the GPT in that link. In the GP2, yeah, so the GP2, I think it's a much larger model size comparing to GPT-1. So maybe let me just show you the model size of, so this is that link. So let me just quickly show you what's the size. So yeah, so you see the GPT-1 is just the 100 million. And the GPT-2 is like 1.5 billion, and GPT-3 is like 100, like almost like 200, like 175 billion parameters. So you see the size. So basically, the improvement for the performance is mainly contributed by the model size and the additional data sets it used to train that model. And you can also see the token size, right? So token is kind of like how many previous word, like how many words it can encode. So like GPT-1 is like 500, and then GPT-3 is like 2,000 token. So it can take like a 2,000 tokens. Basically, it can kind of contain all the information in 2,000 words.
Do you know how this relates to gigabytes?
You mean the size of the model in gigabytes?
Exactly.
Yeah, that I don't. Yeah, so the parameters, you can think of the parameters as I don't know if it's a float, right? So based on whether you want to use 4-byte and 32 float, kind of for the parameters, right? So say we are using like a 4-byte, so like a 117 like billion multiplied by 4. So that's a byte. That's a byte size. If the parameter is like we treat it as float, like a 4-byte length.
Great information. Thank you.
Okay. So you understand the difference, right? So it's basically the data set is trained on, and also the size. And of course, there are some additional tricks in terms of how to improve the model in terms of this zero-shot performance, etc. So what does zero-shot mean? So zero-shot means like without additional training, like without additional gradient update, it can fulfill the task directly. For example, if you just show this paragraph and then you prompt the question as like, did they climb any mountains? And then it will directly gives you the answer. So it can directly do a reading comprehension task. And also it can do a zero-shot summarization, just given paragraphs. And then if you give it like this kind of like delimiter or tells the machine, okay, do a summarization for me, and then you will output a summary directly for that paragraphs. And also doing the zero-shot translation is the prompt will be, okay, the sentence is in French, right? And then you just directly say, okay, translate it from French to English, and it means, and then the model will tends to generate the English translation of French. And here is just shows the performance of the zero-shot translation. And actually, I don't think, yeah. So I still not like a comparable to the translation with actual labels. Actual labels means that you have the sentence pair like a French and English, and then you train the model. And that translation that Google Translate already did a very good job just by training on the labeled sentence pairs. While here it's just a zero-shot translation, means that it doesn't, you don't give those labels. You directly ask the machine to translate. And right now the blue score kind of tells like how good that sentence output is. So it works to some degree, but not that great. So if you like a human to do it, then it will reach like even 60 score or like a 70 blue score there. But for this, like the zero-shot performance without any labels, it can do like above 10 score. But even though like it's not that great, but it says something that actually learns across the multilingual, like some information like multilingual as well, right? So even though it's not that great, but in terms of the zero-shot performance, I think it's working. It's showing some progress in the learning the multilingual features. The GPT-3, well, with like 175 billion parameters, and then people start using it for the meta learning. So the meta learning is basically a framework that will train the model on many different tasks, right? So for example, you just show the machine like a different type of task. So for example, it's a submission, summation.
1, 2, 3, 1, 2, 3. 1, 2, 3.
So this summation, and then this like a correction of the word,
1, 2,
or
3.
like a change the yeah, and then change the kind of the translation, right? So you just show the machine like many different types of task, And then the out of loop is the model will be trained across different tasks. Maybe you can present it like hundreds or even more different tasks and let the machine train on that. And then at the inference time, you just showing this sequence, right? Just say maybe a subtraction this time and showing the sequence, and then the model can auto complete the following. Say if it's like a 9 + 8 equals, and then you let the model to generate the next word, which hopes to be a summation of these 2 digits, and then it will directly gives you that output. So what it means that this model, once it sees through many tasks, right, and then learns itself like how to complete a task, and once you present it with a new task that it has never seen before, it can generate, it can complete the task in some degree for you. So this is a basic idea of the meta learning, like the GPT-3 model that can fulfill different tasks. Well, and actually the performance is is of course not 100%, and I think people start observing that when they use a ChatGPT, right? So if you give it some summation or some like calculus, it actually doesn't do like 100% great job there. And here it shows like, again, this is the scale and this is accuracy. And then this is like a few shot is like you present some, say 3 examples to the machine, and then you give it the 4th one and let it to generate the output and to see whether this is accurate or not. And you can see that the GPT model, GPT-3, can do a pretty good job up to 100% for the 2-digit addition and subtraction. And then starts following is the 3-digit, while the 4-digit is accuracy is like only 20% over there, right? So the more difficult the calculus, the lower the accuracy that GPT can actually generate. Yeah, so this is like also the word and scrambling. Like what is the performance? Like if it's random insertion or some like me too word, etc. So you will see the performance. But usually, as you can see, just like as long as the your language, your model size increases, the performance usually will get better in terms of the few shot performance. So when I say few shot, is this, right? So you just give it a few examples, and then it gives you the output for the inference input. Yeah, so they even create a general chart in terms of the performance across many different tasks and benchmarks. So this is a few shot, and this is a 1 shot, and this is a 0 shot. 0 shot is you won't show the examples even. You just directly gives like what is 100 plus 200, and then it lets the machine gives the output. So this is a 0 shot. 1 shot, you give it like a 1 example. You tell the machine 100 plus 200 is 300. And then you ask, okay, right now, what is the 200 plus 300, right? So this is like a give the machine 1 example. And few shot is like you can give the machine like 3 examples or more. So you can see the performance kind of will gradually improves as you increase the model size. And also like when you give more examples also help, right? Give your more examples kind of helps the model to adapt to the new task. Yeah. Any question?
Yes, this seems like such an inefficient way to learn how to do math. And I'm wondering, is it possible to train the system so that it knows when it's better to switch to a more traditional approach?
Mm-hmm. Yeah, so this is like a general GPT language model, right? So the language model is always to given a prompt input, the goal is always to generate the next output. So it's like this general form across all tasks. But on top of that, you can still do like this calculus-based. You can fine-tune the model for specialized direction, such as like do the calculus or write code. I will show an example later on, like how it fine-tunes the GPT to generate the codes for the task.
Okay. All right, thank you.
Yeah, hi.
Hi.
I had a similar question. Do you know if there was any benchmarking done between, say, GPT-3 and just doing a straight search? Like I saw an example where someone asked ChatGPT how to install Open Computer Vision, and what it returned was the same thing I got, you know, just by doing a Google search for install OpenCV. So you understand what I'm saying? Was there any sort of benchmark between just a straight search, you know, a depth or breadth search, and synthesizing it with a transformer?
I don't see there's a benchmark because I think the purpose is different, and always like Google always doesn't. I think it doesn't give you the answer directly always at the first link. So I think it's more like a metric of how often do you see that you get your answer directly at the first link versus you have to browse a few pages to get that. But in terms of the language model, yeah, so if there's a direct answer, it will directly output there. But if not, I think it will trying to generalize to get you a more generalized and direct answer for that. But I think it's a different type of task. So that the link, like which link is more relevant, is more like a information retrieval to identify to basically do a matching of what you ask versus what content exists already there. But the GPT is kind of, it can generate the new content itself. So maybe the content it generates doesn't exist. Yeah. So it's more flexible.
Yes, and I think everybody's just trying to understand sort of the parameters of, you know, the use cases.
Yeah. Yeah.
In ChatGPT's defense, if you see something in ChatGPT, you're not going to see any ad for it, other than of course the ad for ChatGPT. Well, if you are going to search for install OpenCV and you click on a page, you have to go ahead and see all the ads on that page.
Yeah.
So you're skipping ads when you're having something generate content for you, because you have the content. You don't have the content plus whatever else is on the website.
Yeah. Any other?
We
Yeah.
didn't.
That's all I wanted to say.
Yeah, I have a question. Within a transformer, what is the objective function? What is the optimization in that going on? So we know in the neural networks, we have this loss minimization, but in a transformer, unsupervised learning, what are we optimizing in the transformer?
Yeah, so it's the autoaggressive model, which is always to predict the next word. Right. So in the unsupervised, it's like you always taken, say, the previous, say, 100 words, and then you take that as the input, and then you trying to generate the next word and maximize the probability for the word generated versus the actual word subsequent to that 100 words.
So it still sounds like it will be supervised, right? The next word will be the label.
Yeah. It kind of like the labels, but the label doesn't require any human beings to label it. It itself exists in the text already.
Yeah, thank you. I understood.
Yeah. Okay. And then so this is actually talking about that, like an autoregressive language model is universal. It also shows some example of the GPT is actually doing the next word prediction and trying to make the next word prediction as accurate as possible, like comparing to the actual word, actual next word. That is the objective. And it can pre-train on the internet, basically all the free public text. It can pre-train on the internet and then fine tune on a different task. Yeah, so you can also do the zero shot and fine tuning. And people actually think that they also can transfer to images, right? So the GPT is doing the next word prediction, images is doing next pixel prediction. You can also train on unlabeled images such as ImageNet and fine tune it on other classification tasks. So let's see some examples over here. For example, this iGPT completion is basically you just prompt the model with the pixels of the images, like the first half of the catch, and then it will the iGPT model will generate the next half of the pixel value in that, right? So you can see like a different variations of the output. Same over here, right? So you just show the upper half of the images, and then the GPT will automatically complete the next half images. I think the idea is very interesting. Like you can basically transfer the GPT model from the language space, the word space to the image space, which is the pixel, right? So predict the next pixel based on the previously observed pixels. And people also train like a GPT and use it to do the text to image generations. I guess you may also heard of that, right? So just give paragraphs like describing what you hope to see in the image. And this is your prompt, right? So in terms of the GPT, so this is your prompt, your input, which is a description. And then your output is pixel values. So you directly, the GPT automatically completes the next the pixel values, kind of like match like what you hope to see in that images. But actually, technology-wise, I don't think it's a lot difference in terms of for language generation. So language generation is to predict the word and complete the paragraph. While this image to text to image is you predict the next pixels and then and complete the whole image from that. Yeah, I think the idea, the transfer is pretty cool. And realize uses the same generative model in both language and in computer vision. This is another example showing that you want to have a storefront that has the OpenAI on it, right? So it will, based on your description, will generate various kinds of OpenAI storefront. Well, some for storefront is misspelled also, right? Yeah, so it's even different styles over there. Yeah, but I think it's a very interesting use case. Like previously, we talk about the text to image. We can also do image to image. So here is like you show input image, and then the output is the sketches of the cat, and then you just show a few examples, and then if you give the fourth example, and then it will output the sketches of the input image as such, right? So if you show the machine like the vertical reflection, and it will automatically learn that, oh, I need to kind of reverse the pixels over there. So I think there's lots of applications in terms of this zero shot learning or few shot learning performance. Okay, I think I want to also put some time on the codex because I feel it's pretty cool. If I think I would want to have such a tool that will write some code blocks for me And then I can maybe adapt it to the task I want. So I think it's a pretty cool applications of the codex. So the idea is, can we, it did worse, or can we just train a GPT model on writing codes, right? So the prompt is like what you hope to accomplish, with the Python or with the C++. Yeah, you can even specify the language there. And you just tell the model like what you hope to accomplish, maybe and these some test examples, and then it will automatically complete the codes, which is the output to your prompt. Yeah, so the GPT-3, like without training it on specifically labels on codes, it can write some codes already from a docstring or method name. So here is some examples, right? Say this is your prompt input, which is your function name, a description, and some examples. And then this is your output, right? So this is the output, which is actually the function body doing the actual work. Yeah, so, and this is your kind of your unit test to test whether that function is doing the job it does. So basically, the machine will generate like lots of like this function body codes. And then it will run through this test to see whether that function is valid or not, right? So you can basically evaluate the output from the GPT model. And then the metric it uses is the pass at k matrix. So it tells that, say, for that function description, I give the model 100 chances to give me an output. So it will give you like 100 pieces of codes for the function body. And then the metric measures the probability that at least one of the 100 samples is correct. So it means that function body will pass the unit test. So maybe you output 100 function calls, and maybe 1 or 2, or maybe even more will pass the unit test. So that measures the like at least 1. So if at least 1 succeed, then we call it a success. So say we have the GPT model, right? So we have the GPT-3 model, and remember that is trained trained on unsupervised data only, like just to do the language modeling. While here, in order to adapt it to a new task, say the writing codes, and actually they specifically connect this many codes collected from 56 million repositories. And it fine-tuned the GPT-3 models of different sizes to the code. Just let's kind of adapt the GPT to learn how to write codes in different languages and also the writing style. And what's special is that the code, sometimes the space is special, right? But for languages, the space sometimes doesn't mean much, but for coding, the space is very important, right? So they specifically add tokens or to learn the embeddings for the actual spaces as well. So a very easy problem, say you want to increment the return list with elements incremented by 1, right? So this is your input. This is your kind of the prompt input. And then this is the machine, the model gives you the output based on your prompt. And then the pass at 1 rate is pretty high. So you just give the model 1 chance to generate the output. And 9 out of 10 times, it will pass the unit test. It actually generates the right code for that task. A medium a problem. So this is, I think, is a more complicated writing problem, right? So you see that the performance actually dropped from 0.9 for the easy task to like 0.17. So out of 100 outputs, only 17 is able to pass the unit test from that. And also it can be an even harder problem, which is like you provide an encoder function, right? So you tell the machine how you encode the inputs, and then you give the instruction, okay, take the input string, encode it with this encoding function, and you decode the string for me and returns the original input, right? So this is your kind of input up here, like from the you tell the machine you have the encoder function. Well, maybe you can ask the machine to write the encoder function for you, but here I think it's a more challenging. Or let the machine to write the encoder function, like match your descriptions, and then you take all of this together as your input, and let the machine to figure out okay how to write a decoder function based on your input. So you can see the pass rate is even smaller. So you very likely you cannot find a solution to that. Yeah, so there will be different pass and K performance, and also this is like a number of samples it generates. And the best and then you see here there's the temperature. So temperature kind of showing the diversity of your outputs. So temperature, if it's 0, it means that you always generate the same input. The model will always give you the same input. So if you increase the temperature, the model will give you more diversified inputs. So you know that when you increase your temperature, actually you will get more diversified outputs, and then it may be like there will be a higher chance for that one out of 100 outputs will pass the unit tests for that. Yeah, and then it also learns like there's effectiveness between the metric, the performance pass at K versus the model size. So same observation, right? So the larger the model size, the more likely that the code outputs will pass the unit test. And it further then compare the output versus the output an oracle, like basically it will run through all the outputs to unit test, right, and directly pick the one that kind of can pass. So that is the solution it can find. But most of the time you don't have the unit test, right? So say you just have the input descriptions, and then you need to learn to rank those 100 outputs, like which is the most likely codes that will give you the straight direct answer. So basically, like in addition to the oracle test, it will have like a different ways to rank those 100 outputs, and then here is the performance on that. So yeah, I find it quite interesting. Well, ideally is like maybe you will need to write a unit test to automatically check which is the right answer or right codes for that. And according to their observation, they think some mean log, so kind of the mean probability of the outputs, gives you relatively a better performance over there. Yeah, so training the code supervised, it fine-tuned that code, like a GPT-3 fine-tuned on the coding repositories. And then it further fine-tuned that model on standalone functions which are correct. So it kind of gives you some labels to see that, okay, based on this description, these function codes are correct. So it adds some supervision to the model training. And then you will see a boost of performance, right? So you will see a boost of performance from the code only, like without seeing, just by training on the repositories without, doing this description and code match, versus like you add some supervision and you provide some labels for the model. So you usually, like with additional labels, you will see a boost of performance in terms of generating the right codes for that. Yeah, so the purple one is like if you have the unit test, right? So you can always run, basically you just generate 100 or even 1000 outputs and just run through the unit test, and then the one which passed is the answer to that. So there's still some limitation in terms of the codex. So one is binding. So binding means that you have a sequence of operations. So add 3 to y, subtract from x and w, and return the product, right? So right now the machine still kind of get confused. It still cannot catch up with the longer kind of logics. I don't think it still can capture that long logics. Same as the composition, right? Say you want to write a bigger block, and each block is doing something. Say what the first block is doing pre-processing, the second code block is doing the feature transformation, third block is doing model training. So if you put all of this together, the model cannot do a great job. But if you put like a 1 by 1, right? So you just prompt it with say doing some data cleaning operations, very straightforward, the model can complete that for you. So there's still some limitations in terms of how to generate the codes based on a longer sequence of logics and longer, bigger blocks, like in subsequent steps. The codes still have challenges to get the direct answers for that. So you see, you just provide an instruction over here. And then the codex will automatically write the codes for you. So for example, download the weather data from for this and use what. So once you give the instruction, like in a very natural language way, of course the instruction gives like a very specific, and then it will automatically like write the codes for you. And the GPT team claims that actually until this point, all the codes it generates can run, can run directly. It's just that some of the codes may not give you the right outputs, so you will need some tweaks to generate that. But I think most of it is pretty like automatic. So this is a Python example. And here is even, I don't know the exact language, but I think it's a pretty cool example of like you can directly write a game by just giving this natural language example instructions. So you will directly write like this. And later on, you can even, let it move, right? So you can just say animate this horizontally, bouncing it off and left and right, and it will just write the codes for you, and you will see the what it will look like. Yeah, that is called DEX. So I feel it's although it's still at very early phases of codex, but I really feel like yeah, it can already complete many of these basic functions. Yeah. Any question for codex comment before I move to the conclusion?
Yes, I was wondering, is it possible to feed the chatbot's own code to itself in a query as part of a query and ask it to change or improve it in some way, and then run that code through your metrics and see if it could reprogram itself and improve itself?
Yeah. So I do have an example that I know one of my teammates previously, they have a code, they write a code, but it has an error, right? So it has some bug error that it has an error message. So and then they directly give the input codes and then give the error message and then ask the GPT to correct it, and it does the job. Yeah,
So
just
So go ahead, say what you were going to say.
Yeah, I mean, just like a rephrase. People I know, people right now using the ChatGPT to rephrase or make their phrases better, improve their writings with the ChatGPT, right? And actually, I think people also use the ChatGPT to improve their codes.
Right. I'm just wondering if you could have it running off in the corner somewhere, improving itself constantly. And, you know, in a week or a month from now, you might end up with a much better system.
Yeah, that is future work, and to see whether it can be directly integrated with the existing software. But I think that will also requires improvement, because I don't think we want just directly want the codes in production. But if you can write all the very good unit tests and integration tests to make sure that it doing exact job you want, then yes, I think that's the option.
Yeah, after a while, you wouldn't know how it works, and you maybe wouldn't care. I don't know.
Yeah, but I think in strict software space, we still need to do the code reviews and all that. So maybe in future you will make the process much easier, like the code review process.
Yeah.
Anyone else? Yeah, I think here is a very cool examples. Yeah. And I think it's maybe also a very good education tool, right? Just to learn yourself. And maybe in future, I feel like the people, who can give the right instructions know how to tweak the output from this, and also know how to kind of further improve based on the outputs. Kind of win the job market. I feel because I feel like maybe the basic functions or the code block maybe can be generated by this Codex GPT model, but I think it still requires humans to define what is the right instructions to give, and also in terms of the system design, and in terms of to make sure that the codes are valid and the integration tests can pass. And the whole design over there will still require a human expert opinions in that. But it will definitely, I think, can be used as a tool to increase the efficiency. At least it saves some efforts in terms of copy and paste, I think. To give you directly the code block you want.
How is this code different from the code that passed the Turing test initially?
Which code?
The code that passed the Turing test. I think it passed sometime around 2015, 2017, something like that.
Yeah, so the Turing test is to see whether that code is written by a human or not. Is that
exactly?
Yeah. Yeah, I don't know what system they are generating the codes.
Okay.
But over here, I don't think it's like this. It's more like it's like this. Like you give the instructions, and then it output the codes that match your instructions. If you just let the machine without any prior instructions and just let it to output the codes, then maybe that is what it refers to a while back. But here is you give the specific instructions in languages and then generate the codes that fulfill your task. I think this happens recently, but not that time.
Right.
Yeah. So that's pretty much of today's session. So yeah, the conclusion is the progress is very rapid. So the GPT is based on the beginning model, or the base model of the GPT is based on training on data sets in an unsupervised way. Well, the unsupervised means a human does not have to provide additional labels, right? The labels can be kind of directly programmed from the data set itself. And it's done through autoregressive modeling, which is basically doing the next word prediction task, right? Based on the previous sequence, what is the next word? This is quite universal, and you can transfer this function to images completion, and also to text to image completion. And then they also show like how to further fine-tune the GPT-3 model on codes, and it becomes the codex solutions from OpenAI. And it says that usually you cannot directly generate like the answer directly. So usually you give a sampling, right? You instead of generating one, you generate like 100 outputs, and from that 100 outputs, you select the best one. Or you, if you have the unit test, you can just find the answer from that 100 pool. So it gives you a more robust way to find the answer for that. Because right now the model cannot guarantee that a one-time generation will give you the direct output.